Hello, my name is Austin Rodriguez. I'm a student here at DeVry University. I'm currently enrolled in the Applied Projects Lab, ECT 295L, for the September 2017 session under Professor Hudgens, and this is my DC power supply project. The intent for this project was to take components from appliances found around the house and convert them into an adjustable power supply that can output anywhere from 6 volts to 12 volts. The exceptions to the components found around the house that we will be using in this project would be a perf board used to house the circuit, as well as the terminal strip used to make connections to the circuit itself. My bill of materials stretches over 2 slides. On this slide are the components that are most easily found around the house. The 560 ohm resistor, the two 1N4001 diodes, the 0.1 UF capacitor, and the 110 UF capacitor are most easily located. I found these within television remotes, the toaster that I no longer use, as well as unused monitors housed these components. Here I have a picture of the 560 ohm resistor as well as the diodes and what they look like. And here I have pictures of the 0.1 UF capacitor and the 10 UF capacitor. The 0.1 UF being on the left, the 10 UF being on the right. The second page of the bill of materials goes on to contain the more challenging components to find around the house. This includes the LM3 17T voltage regulator, the 0 to 5K linear potentiometer, an SPST switch, terminal strip, heatsink, 12 volt wall wart, and perf board. Now again, the perf board and terminal strip were not included in my home search. However, the rest of these did find themselves hard to locate. I ended up tearing apart an old radio, a stereo system, an alarm clock, and some toggle switch toys that I had around the house. You would think the 12 volt wall wart would be easier to find, however, most of the wall warts I had around the home were either 5 volts or 10 volts. I could not find a 12 volt one no matter how hard I tried. Here we have a picture of the regulator and the heatsink, as well as pictures of the potentiometer, switch, and terminal strip in left to right order. My entire bill of materials went on to cost around $43.96. This is due to the fact that I purchased twice the amount of bill of material components than necessary. This was to ensure that the risk for human error on my part with mishandling parts or short-circuiting some parts, as well as faulty parts being sent to me in the mail, could quickly and easily be replaced, and I would not have to order them again. I tested the same circuit layout given to us in the reference material in the multisim software. I got the same results that I was looking for, and so I decided to keep the same circuit layout for my own design. I also attempted to keep the perf board layout the same as the reference link given to us. As you can see here, he's got the top view on the left side and the bottom view on the right side. The top view being the side where the components are, and the bottom side on the right being where all the wire connections would be. The only noticeable difference between the two projects, my layout and his layout, is that mine is significantly larger due to the component size. Here I've included the circuits side by side in order to compare. I said there weren't too many noticeable differences, but as you can see, it's hard to really call them the exact same layout. One of the more noticeable differences is that my wire connections all run underneath the perf board so as to avoid the unsightly scenes of the wires. Some of the components are slightly larger than the others, most noticeably the terminal strip, which I couldn't find one of just the one connection. So I had to make do with what I had and make room for the terminal strip. Um, Instead of having the diagonal diode, I opted to keep mine vertical on the right side, and I pulled the zero point 0.1 UF capacitor off of the side of the switch and spaced them out. Another noticeable difference would be that to avoid crossing wires, like shown in the left side with the still covered wire, I ran my wires down through and back up the top of the perf board to completely get out of the crossing wires section. When I initially went into testing the part while it was powered, I couldn't get a voltage reading over 4 volts. It ranged anywhere from 3 to 4, depending on how the connections went. Now this is because when I put the circuit together the first time, the maximum voltage output was reduced by a reversed orientation of the second diode, the vertical diode, in my circuit. Due to this reversed orientation, it caused the 10 UF capacitor to blow out, and I had to go in and solder the parts off of the circuit and then resolder new components back on. After replacing the components, I tested each one of them individually to make sure they were properly working, and then I went into the final testing period of my circuit while it was powered. During this period, I ran the tests and tried to get as close to 6 and 12 volts as I could, and found I was pretty much successful. Pictures shown at the bottom are the voltages reading from 6 and just under 12 volts. Here I've included a video of me trying the circuit and shifting it from 6 volts to 12 volts. I set it to as close to 6 volts as I could to start off with, powered it on, and then adjusted it from 6 to 12. In closing, the things I learned over the course of this project is that overstocking components is very important. You never know when you're going to run into an issue with a component in the production of your project. Layouts can be very flexible. I was worried that I would have to run all of my connections over the top in the same fashion as the reference project given to us, but I found that it worked just fine with the leads running underneath. Also, component orientation is key. If you have some parts facing in the wrong direction, not only will the components possibly burn out, short out, but also the project itself just will not work properly unless the component layout is fixed. For the sources page, all I have is the link that leads to the reference project I was using in order to base mine off of. The only other sources I could think of to mention would be going to RadioShack.com or Amazon.com to order my parts. I hope this presentation was informational, and thank you for taking the time to watch and read it.